Okay, we'll start. So what we're going to look at in this lesson is vectors. Does anyone know this word, vectors?
Yes.
Oh, you all know it.
Hello.
You know vectors?
That's the math class.
Huh?
That's the math class discussed.
Say that again. Math class?
Yeah.
You did it in math class before? Good. But can you explain what a vector is? That's the other question. Do you want to try, Louise?
Can talk.
You can talk, yeah, it's okay. Does someone else want to try and tell me what a vector is?
You have direction.
Very good. It has direction, yes. And what else?
And length.
Length, yes, yeah. There's another word for length, but I know what you mean then. Now, you said you did vectors in math class. You've done vectors before. You said you did vectors here. You've done vectors before? Do you know what a vector is? No. Okay, so I'll show you now. So what we're going to look at is vectors. Vectors and scalars. Okay, who feels like they can give you the definition of a vector? Do you want to, you kind of said it. Come on, don't be shy. A vector is...
I can't go further.
I'll go and try. We're all friends.
I know we're friends, but...
Yes.
but I don't know how to describe it.
Does anyone else want to try? Abraham, do you want to try and describe it?
Yeah. I guess it's direction.
Yeah?
Just
The size.
Has a size, yeah. So, you all have the right idea, okay? A vector has two properties or features, I guess you could say, features. The first one is it has a direction. And the second one, there are many different words here. Size is one word, or you could say magnitude is another one, or a length. Someone said length, you said length, didn't you? Yeah. That's great, but what does that mean? Well, let me give you some examples. So let's say you walk 10 meters per second north. This is a vector because it has a direction. What's the direction? North. And it has a size. What's the size? 10 meters per second. Okay, what about this one? Sorry, 10 meters per second is too fast for 1.0. You run home at 5 meters per second. What do you think? Is that a vector or not? It is. Well, it is because the direction is towards home. And the size is 5 meters per second. So these are all vectors. Now, let's do something which is not a vector. Now this one is not a vector. Why not? What is it missing? No direction. It just has a magnitude. But it doesn't have a direction. And then here's another example of one that's not a vector. Walk home. It's not a vector. What's it missing? Well, it has a direction, because you're walking home. It's missing a magnitude, isn't it? So this here is not a vector. Also, okay, so that's vectors. Now, next is the second part of the title, which is scalars. So the first half here are vectors. And then the second half now would be scalar. So, who knows this word?
Scalar is just a magnitude.
Yeah.
Yes, sorry.
Just the size, just the magnitude. Yeah, so a scalar has only magnitude. So in fact, in my 4 examples, one of them is a scalar. Which one is the scalar?
Third one.
The third one is a scalar. It has only a magnitude and no direction. So this is the only one that's a scalar. Let's have some other examples. So for example, mass equals 5 kilograms. That's a scalar. Example, a person's height equals 1.6 meters. That's a scalar. Example, let's do one more. Charge, yeah. Well, no, I want to do something you already know. What else do we do? Time, yeah. We'll do time equals 5 seconds. These are all scalars. Scalar, scalar, scalar. So, to just summarize and then we move on, a scalar has only magnitude, but a vector has both magnitude and direction. Now the reason I'm writing this sentence out is because I'll put a box around it. It's very common in the exam, this question, explain the difference between a vector and a scalar. It's a common question in the exam. So this here is important for the exam. So note. Okay. So now we're going to talk a bit more about vectors. Well, actually, you know what? Just before we do that, I just want to give you a famous example as an example of a difference between a vector and a scalar. So, speed is a scalar. So speeds are like 5 meters per second, 10 meters per second, etc. But be careful, this word here, velocity, that actually is a vector. So for example, you could have 5 meters per second, you could have minus 5 meters per second. That means 5 meters per second backwards. Okay. So what I'm saying is here, velocity is the same thing as speed, but you add a direction as well. And one way you could add a direction is by putting a plus or minus in the front to show if it's forward or backwards. But that only works, of course, if you're moving in a straight line. What we're going to look at next is movement in 2 dimensions. Okay. Oh, sorry, you can't quite see that there. Maybe I'll just raise it a little bit. Yeah, perfect. Okay, can I move on? Yes, yeah. Okay. So, how do we represent a vector? I mean, this is maths and physics. We can't represent vectors like this, 10 meters per second north. We need some kind of mathematical way of representing it. And the way we represent vectors is as follows, with an arrow. So this is how we represent a vector. We draw an arrow. So this arrow has 2 features, just like a vector. It has a direction because it points somewhere, doesn't it? And it has a magnitude, it has a length. So, for example, this vector here, this could represent 10 meters per second north. This vector here could represent 10 meters per second south. Now, look at those two that I drew. What do you think this vector represents? Yeah, that would be 5 meters per second north. And what about this one?
5 meters per second.
Yeah, 5 meters per second northeast. Okay, so what I'm trying to say is that length is important. It tells you how big the magnitude, how big the vector is. Okay, so if this is half, then it should be half the length also. Can I scroll down? Yeah? Okay, so vector A, to represent that A is a vector, we put a little arrow on the top. So this is vector A. So this is vector a half A. It's literally the same vector but half the length. What do you think the vector minus A is?
Opposite direction.
Yeah, just the opposite direction. So it's just like this. And then let's say the vector, I can't fit it in, let's say the vector minus a half A would be like this vector. Yeah? Okay? So I'm just really playing with the idea here of how to draw them. Okay. Let's say this vector is a length of 10 meters. So this is 10 meters northeast. What do you think this one is? That's 10 meters northeast, isn't it? And that one here, 10 meters northeast. The point I'm making here, it doesn't matter where you draw the vector. So you can put it anywhere. The only thing that matters is it still 10 meters and is it still northeast? The answer is yes. These are all the same. Okay. Now I think we're ready to look at how to add two vectors together. Okay. So how to add vectors. So let's say we have this vector here, A, and then we have, let's say, this vector here, B. So I want to add these two vectors together. Why do you think you would need to add them? Well, I'll give you an example. You know, if I say to you, go 10 meters northeast, and then go 10 meters east, then you only really care about the final position, you know. Like if I say, okay, you go 10 meters north, then 10 meters east, then 10 meters south, you really just care what the three of them add together is. You don't really care about the process to get in there so much. What we need to do first is move this vector to be at the end of this one. Yeah. So what I've done there is I just drew this here. I moved this here like that. Now I'll show you how to do it more accurately in a moment, but I just want to give you the basic idea. When you have two vectors and you want to add them together, you put one vector at the end of the other vector, and then the answer is this. Roughly, sorry. That's A plus B. So imagine I say 10 meters northeast, 10 meters east, then I don't know, what's this, about 12 meters at about 40 degrees, or whatever it is, okay? So I'm just showing you the concept, the idea that to add two vectors together, you put the tail with the head, the bottom with the top. So if you had 3 vectors, it's the same idea. They just go like a chain, like a link. But that's not very accurate because you have to move the vectors. So let's look at a more accurate example. Most of the time when they ask you to add 2 vectors together, or when you need to add 2 vectors together, they're usually like this. A here, for example, and B here. So if I want to add these together, I should move A to be at the end here, so it can go like a chain. Yeah? But the easiest way to do that, the neatest way to do that, is you start here and you draw a line that's parallel, you know this word from math class, parallel to B, and then you start here and draw a line that's parallel to A. And then where they meet, that's the answer. So this here is the vector A plus B. Now what I would really, they're not so parallel, what I would really love is a little animation, which I'll try and find now. But what you need to imagine is, here's A, and then here's B. And can you imagine B sliding up until it clicks here? Then this is A plus B. Or imagine A sliding along to here, and it clicks in, and then you have B plus A. And I hope you also notice now from this diagram that A plus B is the same as B plus A. So when you add vectors, it's not so important about the order. I wonder if I have internet here. I do. That's a good start. Okay. So I'll give you a little example to do just to practice. Can I scroll down? Yeah. So what I'd like you to do is to draw a vector to the east and then draw a vector to the northeast and give them the same length. And I would like you to add these for me. You got that? This one is exactly east and this one is exactly northeast. Well, I'm sure Wikipedia has a little animation. I don't understand it. I put in adding vectors and for some reason I get this. How can I get a little video?
You just click on it and it's going to load up.
And then I can tell if it's animated?
Yeah. Usually because Google Images and just start showing images like this.
Yeah. I just would have thought Wikipedia would have had something. Maybe. Let's hope for the best. It's animated, but it's not what I want. Oh, that's a shame. I thought I could easily find some animated parallelogram rule for vectors addition. All right. Wikipedia, where are you? Ah, here we go. I really would think should be something animated. No animations. That's a terrible shame. No, okay, no good. Alright, you just have to use your imagination then, okay? So, do you have an answer drawn for me? Yep, okay. So, parallel this way, and your answer should look like, like this.
Yeah.
Do you get something like that? Okay, good. Now, let's look at more complicated ones. So, here is A, and then here is B, but this time I want, let's say, 2A minus B. So it's not as simple as A plus B now. I think I'll let you try and see if you can do it first, and then I'll do the answer, okay? So just try this. Draw the same vector as the last example and see if you can give me this, if you can figure it out. Hamish, are you still out there? No, I guess he's gone. You will soon learn that I'm your busiest teacher. I have the most classes to teach, but I'm sure you're figuring that out already. I think I told you last week the September students had their end of semester 1 exams, so I'm correcting those at the moment. So they're interesting, because most students, they either do really well or really badly. You don't really get so many people in the middle. Because I feel like if you're good at maths, you'll do well, and if you're bad at maths, you won't do well. But if you're in the middle, you'll either be lazy and do bad, or work hard and do well. So you don't really get people in the middle. Okay, do we have that done? Not yet? Okay. You think you have it, Louise?
Yes.
Show me what you drew. Yes, I think that's okay. Yeah, that's it.
Just really?
Well, I can't quite see, but I think it's okay. Where is your answer?
Which answer?
This here is the answer, is it?
The minus.
Yeah, that's it. That's the answer there. This one here.
Yeah, this one.
Yes, that's it there, yeah. Louise, what did you do in Hong Kong? Did you craftsmanship or something, or what was it?
Actually, I studied the media.
Media, okay.
The high diploma.
Why am I thinking draftsmanship or something else? It was media, was it?
Yeah.
Yeah. So, did you tell me something, or maybe you were telling me what you want to study next year?
Oh yeah, the next year.
Yeah.
Social engineering.
Engineering.
Yeah.
Okay.
People.
Social?
People engineering.
Civil engineering. You told me this,
Yeah.
I think. I don't remember.
Yes,
Do you know which university?
yeah, I think.
Cool. So you can stay in Dublin. Good. Do you know what grades they want?
It's
B's and C's probably.
anything.
I think C.
Maybe 2 B's, 2 C's or something?
2 C, 2 B.
Yep, that's what I said. Yeah, 2 B's and 2 C's, yeah. That's usually what they want, yeah.
The physics B2B and then the math also B2B.
Oh, they want the B's in physics and maths.
Yeah.
So you get C in chemistry, C in English.
Yes.
I think this is better this way.
Galway is C?
Galway is usual. It depends on the course.
C,
Well, it depends on the course. Computer science,
the same.
civil engineering. I think it's like 2 B's, 2 C's, or maybe 1 B and 3 C's. Like this.
They write in the letter C.
Did they just say C?
Yeah.
So I don't know all the courses. I know I know computer science is C. Did they say 1 C or 4 C's? Were they talking about EAP or all the subjects?
No, all.
Oh, so 4 C's?
Yeah.
Okay. Well, that's okay. Yeah. I mean, you're happy with that, or?
Yeah, I think, yeah.
Yeah. You know your one already, don't you? You looked at it. It's in Leeds? Yeah. A and 3 B's?
3 A's only.
Oh, 3 A's and a B, not 1 A and 3 B's. It's very different.
Yes, first.
Okay, let's have a look at this now. So, I think I saw, Louise, you figured it out, that first we should figure out 2A. So that's 2A. And then we need to get minus B. So if that's B, then this one here is minus B. Now let me remove this here. Okay, so I'll do it in blue here. So this one here now and this one here is what you want to add. And you can actually forget about this. We don't need it anymore. So now in, I don't know, what colour have I got left? Black. We draw our line here. We draw a line here. Then we get rid of this stuff here. And then in, back to red. Here. Did you have this, Louise, or was it the other way around, actually?
Why did it the other way around?
Actually.
Yeah, actually, should be this way. Should be this way. Yeah. Yeah, because if you put this at the end here, it goes this way. I think, did you do it going that way? Yeah, I think the other way. Yeah. Well, anyways, you can add it into your notebook now. Abraham, did you get it this way or the other way? No, so everybody did it the other way, maybe? Who? Which way? Did you do it this way or the other way? Who?
I don't think this was okay.
Let's see. Yes, that is the same.
Yeah, just parallel.
But yeah, it's parallel to it, yeah. I want to give you a little bit of vocabulary, okay? This vector here, the answer, has a special name. It's called the resultant vector. Oh, and I should, well, I mean, it's not something important, but this diagram here, you will not be surprised when I tell you that this is called a vector triangle diagram. Okay, it's not important, but I'll just say it anyways. What is very important is this word, okay, because in the exam it would say something like find the resultant, or I might say construct. What does construct mean?
Make.
Yeah, make, give us more synonyms. Make, draw, sketch, etc., 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 the resultant. Where did Lorraine say she used to see you?
So she go weights from the D213, and then she was going to take because it's a different cost.
D213, is that what it says on your timetable?
Yeah, but she doesn't want a t-shirt, says she noisy.
Yeah, we have a different room. I know which room you're going to, so I'll just take you there directly, okay? I'll let her know that. Yeah, well, I'll text her in a minute. Okay, is there anything else I need to tell you? Oh, yes, one last piece of vocabulary. Can I scroll down? Yeah. Alright. This here is A. Oh, by the way, it's very annoying to put a little arrow on the top every time I want to do a vector. So sometimes I don't bother to write the arrow if it's clear that I mean it's a vector. I'll tell you what, I'll use the letter V for vector. Right, this is a vector. This is half the vector. This is a quarter of the vector, and so on, and so on. So what is this 0V? What's that?
It's lovely.
Yeah, so what exactly do you mean it's nothing?
Point?
Huh?
Point.
It's a point, kind of, isn't it? Is it still a vector? Kind of. Yeah, like maybe it's a scalar now. It's not so clear, is it? Anyways, I'm telling you now that it's still actually a vector, okay? And it's called the null vector. Hey, you'll start in a couple of minutes. I told Michelle to start at 2:10. And the reason she's starting late is because I'm starting late. And the reason I'm starting late is because I finished late in the last one, okay? So you can wait or you can come back. You'll wait or come back? You'll wait? Okay. Oh, battery low. Alright. And I better pause it or stop.